real quick, what's the biggest problem in developing for Internet Explorer?
Internet Explorer.
Only one?
People use it. You're listening to Coding Blocks, episode 35. Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcast app.
Visit us at codingblocks.net where you can find show notes, examples, discussion, and more.
And send your feedback, questions, and rants to comments at codingblocks.net. Follow us on Twitter at codingblocks or head to www.codingblocks.net and find all our social links there at the top of the page. With that, welcome to Coding Blocks. I'm Alan Underwood.
I'm Joe Zach.
And I'm Michael Outlaw. But first, this episode is sponsored by Digitalocean. Over 550,000 developers have already deployed to their cloud. You too could deploy your own droplet in 55 seconds. Their options start at $5 per month, and you only pay for the time used when your droplet is live. Use the offer Coding Blocks and get a $10 credit towards your new DigitalOcean account. All right, and so with that, let's get into the podcast news. What?
All right, we're done.
Yeah.
Okay, so no,
Yeah. I guess, what
we-
was his name? Pano? He'll be happy. We're
Yep.
done.
So I was watching a Fallout trailer.
Oh.
we really only have a couple things this week or this episode. First is Jeff Bellina wrote us about I guess my tip that I had on episode 33 where I discussed SP-Who 2, and he actually wrote in and said, hey, there's something even cooler, and it is called SP_Who is active. And he says it's everything that you love about SP-Who 2 and DBCC input buffer combined with being able to show plan for the running SQL SPIDs. So that's pretty cool. He did leave a couple of links that we'll put down here in the show notes. And he also mentions as well that there is a free tool from, I've even used this company before, SQL Sentry, and it's called Plan Explorer, and it allows you to see like the IO and the CPU for each of those statements as well. So very much appreciate the feedback. We're going to leave it in the show notes, and people can go check that out. And
I feel though, like since he didn't comment at all on the kill tip, then he must have like stopped. As soon as you said your thing, he was like, oh, that's it. I've heard the entire show, and he stopped listening, because otherwise he would have definitely had some tips on the kill SPID.
yeah, without that, there's nothing. So yeah, very much appreciated that. That's a very cool tip, and I haven't gotten to play with it yet. I got this email today, so I'll definitely be trying that out here pretty soon. And then the other one was, we got asked a question on Twitter from Rebecca, and she basically asked, hey, I've been spending time trying to learn this one language, and now I'm wondering, should I stay learning this one language or should I switch over to Java or C# how do I know what to do?
This seems like a song. Should I stay or should I go?
Hey, you want to break out?
Oh, sorry.
So I did write her back a fairly lengthy reply, and I'd love to hear what you guys think too. So I told her, I was like, look, my first thing is I'm not going and learning any kind of random language just for fun. Like if I'm doing it, I'm trying to apply it towards, either work that I can do for a company or work that I can do for myself that can make some money, or there's usually a goal behind it. And so I told her, I was like, look, if you can go and look at the jobs in your area and find out, hey, is there a lot of jobs for what you're spending your time learning, then I think you just stick with that, learn it well, get familiar with it. And then later on, if you need to transition to something else, once you know the fundamentals of any particular programming language, the specifics change a little bit from language to language, but overall, just knowing how the pieces come together, how they operate, the methods that you use, the patterns, those transfer pretty easily from one language to another. So my recommendation was, hey, if there are jobs in your market for what you're already learning, then stick with that. What are your thoughts?
Yeah, I always thought it'd be cool to know one static, one scripting, and one functional language really well, just because, you're pretty well rounded at that point. You've got your bases pretty well covered. But that was a couple of years ago that I thought of that. So now I have to add and JavaScript because everyone needs to know JavaScript now for some reason.
I actually think what she was learning
that
was
can't cover your scripting, or did you mean like shell scripting?
Shell scripting.
Oh, okay.
Okay. Yeah, I mean, what are your thoughts, Outlaw?
Yeah, I don't know. I mean, I felt like we kind of talked about this.
We
in
have
an episode back about like talking about like I think it was like what do you want to be when you grow up, something like that. That was the episode name.
Yeah.
Yeah, I mean, you can't avoid JavaScript. So like Joe said, that's definitely got to be on the list. I liked the added, contextual bit that you put in there about like, well, see what's going on in your area, right, and what your demand is. But then I also thought, well, that could really like, unfortunately, maybe really sway. I don't know. I guess depending on like the workforce that's around you, it may heavily gear towards the language that maybe you honestly don't want to be a part of.
And that's fair too, right?
Right.
Yeah.
But that could just be the demand in your area. So, yeah.
Yeah, there's a lot of ADA around here.
Really?
Yeah, I guess maybe the defense contractors like Lockheed and whatnot.
I think he meant ABBA.
I mean,
ABBA's more popular.
It's kind of weird though. Like, I mean, even thinking about that, like if your area is, let's say, like, I don't know, I would never suggest somebody go to some just really small language. I mean, people will pick those up in their jobs if they have to, but like, I don't know. I guess I would never try and stick yourself into a corner to where the only place you're ever going to be able to work is this one little spot in downtown area that's going to be a 2-hour commute for you or something like that. So I don't know. It's a really
That's
tough.
the one danger about staying towards topic, or, any kind of technology that's specific to your job. That you'll be able to use it in your day to day, but there's that risk that you take to where like the company may not be moving with the times,
Right.
and therefore you fall behind. So yeah, you may be like really up on whatever technology stack they're using, but that's not necessarily in your best interest.
Yeah, in her case, she was actually, I think she said that she was going and taking classes on learning this one particular one, and she wanted to know, hey, is this what I should be doing? And
It was Node and Python.
it was Node and Python.
Let's see.
And it's,
Sorry, I moved away from the mic there, James.
so I don't know. I mean, but I guess my thing is try not to be ADD like most of us developers are, to where you start something and you're like, 5 minutes in, you're like, well, there's something shiny over there. Let me try that, right? Like, spend some time and get more intimately familiar with whatever you're diving into. And then that way you actually really start to understand how things work. And then when you move into something else, like I said, those patterns typically transfer from language to language. So I don't know. That's my take on it. Hopefully, that'll help some of you others out there who are in the same situation. I mean, we got a buddy who loves Erlang and Haskell, right? And it's funny because I'm like, okay, yeah, that's kind of cool, but you're not going to get me to touch it. Like.
Well, I thought you were going to mention another friend of ours who's crazy about Go.
Oh yeah, he's a big fan of Go.
Yep.
So,
although I will mention, I got really into Ruby a long time ago now. And one thing about it is, whenever you do pick up a language, especially if it's really different from the ones that you've worked with, you almost always end up bringing something back. So Ruby is so heavy into the blocks, procs, and lambdas that just kind of, it's really helped me understand the link stuff in like C# a lot better.
That's cool. But, so the language you mentioned, though, is one of the most popular ones out there. Like, I would almost say for anybody that's trying to learn something, go Google, hey, what are the top 10 programming languages, or the top 10 paying programming languages, or something like that. And then that way you can at least see what the popularity index is, right? And then you know that if you're getting one of those top 5, top 10, you're in pretty good shape. Like,
yep.
Well, yeah, you may be covered. You're going to be in a competitive market, right? So you're gonna have to deal with that if you're in those top ones. Yeah, and then you can't even say that you'd be in good shape because it's so competitive. Then financially, it's going to be affected too. So
I don't know.
Those obscure ones might actually pay more.
Well, the obscure
right?
ones will, but you'll be stuck in one place.
Think of.
But like Ruby was one of the top paying ones, right? And so here's the thing.
Well, Stack Overflow, I think we talked about this once before. Didn't Stack Overflow have a poll on this?
Yeah, somebody did. But here's the thing. Like, and I'm not trying to be, I've interviewed a lot of people over time, and it's amazing the amount of people who say they know everything and don't know much. So even if it's a competitive market, as long as you are somebody that is going to take an interview or something like that really seriously and you study up and you polish up, I don't really see that being a problem. And especially if you're somebody trying to get in at a junior level or even an entry level type thing, it's a great way to get in the door and get a ton of experience. But I mean, personally, I would stick with one of the more popular languages just for the reason that, there's going to be positions around.
Yeah, so this is Stack Overflow's 2015 developer survey, and we can have a link in the show notes for this as well. But JavaScript, anyone care to give me a number on JavaScript? Because we've all said it, so we know it's in there.
Like what kind of number? Like salary
a
or
percentage
position?
number? Like, no, in terms of popularity, give me a percentage of where you think JavaScript ranks.
I'm going to say number 2.
That's your percentage?
Oh,
is
percentage?
2?
No, you said where it ranks.
It's one of the most popular languages, and I'm asking you to give me a percentage. Like, what percent of popularity do you think JavaScript is?
On Stack Overflow?
I'm going to say
40.
Okay, Joe says 40% popularity according to the
80.
Stack Overflow technology survey or developer survey, and Alan says 80. So it was 54.4% was the popularity.
Wow.
For that, and that's actually down from 2014, where it was 58.9. And then let's see if you guys can guess
It's the highest one.
Oh man, are you already looking at it? You
Yeah.
cheater!
Yeah, of course I
How
am.
am I going to play this game?
No, there's no game anymore.
Oh my god! All right,
The number 2 one surprises me though.
Joe, are you looking at it? Don't
Nope.
look at it. You're looking at it.
Number 2 for questions, I am going to say SQL.
Yes, sir.
Oh my god!
And number 3?
You're cheating. All right, so
Number
fine.
3, I'll say
SQL,
C#.
SQL, then Java, then C#, and then PHP. So,
Yeah, I mean, like I said, pretty much anything in this list right here, you can't go wrong with. So we will definitely have a link in the show notes. And if you stick with any one of these, you're in pretty good shape. And JavaScript, because it's now client side, server side, and any other side that exists, it's probably not a bad one to pick up. So,
yeah. They go on to talk about like the most loved, the most dreaded, the most wanted. If you've never seen the Stack Overflow developer survey, there's definitely there's definitely some interesting little nuggets of information in there. Like favorite text editor. Just don't even look. Just guess.
Vim.
Notepad.
Or
Notepad.
Emacs.
Okay.
Is it going to be
I'm going to
Emacs?
have to give Joe as being the closest, but it's really Notepad++ was
Oh, I love
the winner.
Notepad plus.
Yeah, Vim was actually a number 4. Well, it was number 3 in terms of popularity, but there was this other category that actually had more percentage. But that's not one particular thing. So we'll give you Vim for number 3. Yeah. So.
No one likes Vim though. No one enjoys it.
But hey,
You're about to get blasted.
the majority of people are on my side with their IDE. They like the dark theme, so I feel like I've been redeemed a little bit there.
I'm a fan.
All right, this poll is total crap.
Although tabs won out over spaces.
Yes,
so
sir. Woo!
I feel like. Wait, what?
I do not like.
What were we
spaces.
talking about? Okay. I think we were trying to answer Rebecca's question, and then I sidetracked us.
Yep. So,
Oh man, news section's so long now.
all right. So that's actually it. That was all of our news. So
Yeah, well, get into the topic then. This is going to be part 3 in our discussion on the 12-factor app. And just kind of a little refresher, the 12-factor methodology is basically for writing applications where the end goal is software as a service, but it also applies to other types of applications that you might be working on. And it grew out of lessons learned among people that have built a bunch of applications, but basically from Heroku. And this time we're going to be talking about port binding, concurrency, and disposability.
all right, we're done.
Yep. So first one up
Wow,
is...
so we're already talked about all that? I'm still on the Stack Overflow developer survey. You guys
we've
already talked
definitely
about the whole
gotten
show.
Well, we've gotten into the weird ones now, so it's a little bit harder to explain some of these items. So We hope you'll bear with us. But
Yeah.
the first one is port binding. You want to take a stab, Alan?
I mean, I will. This one of the three, this one ends up being about the shortest after you kind of understand what they're talking about. So when they say port binding, essentially what it boils down to is you don't, in your app, you don't basically rely on the fact that you're going to have anything on your server that's going to exist for you. If you want something that your app relies on, be it an HTTP server or something like that, you're going to bundle that in your app, and then you're going to bind to a particular port that you're going to listen on. So
It almost sounds counterintuitive to some of the other ones that, when we talked about like dependencies, right? Like this one specifically says that the 12-factor app is completely self-contained, and they specifically call out bringing in like an Apache or a Tomcat or something. And you're like,
yeah, Jetty.
well, wait a minute. Like, wouldn't you ingest, like, wouldn't that be injected?
If it was one of the services, right? Like, because they had talked about email and that kind of thing previously. So, yeah, this one kind of straddles the line a little bit. It makes sense, though. I mean, it really does make sense. If you want to be able to scale up servers quickly, bundling in whatever you absolutely need and being able to make it listen on a port means that you can scale this thing out anywhere. You don't have to rely on an OS version or anything like that. It brings with it what it needs. So it makes a lot of sense.
To me, the most interesting thing here is what it's not doing. And that's kind of like the old school. Like when I started web programming, you would have like Apache set up, and rather than you worrying about scalability, it was more about, adding a new website. So you would go in there, you'd add a new virtual host, or you'd go into IIS, you'd right click and create a new website. And that was more of the focus, was kind of how to run more stuff off of one server and vertically scaling. And now this is really the total opposite of that, where they're wanting to break out everything, and they're actually, dissuading people from using things like Apache and IIS, which were, those were the mainstays for what feels like hundreds of years.
Yeah. Well, I don't necessarily feel like it's going away from Apache, that they're talking about necessarily going away from Apache, but it definitely feels like some of this, I'm assuming that some of this they're implying that, you would, okay, so like in the last episode, we talked about the build, release, run process, right? And
Right.
so I would assume that they're suggesting that some of that bundling for like bringing in Apache or a Tomcat or something like that might happen during that release stage or the build stage rather. Not necessarily. I don't know. Am I saying that right? Because then,
Yeah, I understand what you're saying, but I feel like the way things are going now, like even with ASP.NET 5, that like they're trying to get down to like smaller and smaller web services. So rather than having this big battleship that's like HTTP PD or Apache, which can support multiple hosts and can do all sorts of stuff, and has all sorts of security, and just tons of the config files are crazy for Apache. It's getting down to where you're running these little things like Twisted or a Node web server, or whatever ASP calls it. But things are it's just a tide change, I guess. It's just different.
Yeah, I'm with you.
yeah, but I guess like one of the things that kind of tripped me up though is you'd mentioned the vertical scaling and whatnot, and I kind of, maybe because I was taking into consideration the previous chapters here, that I was kind of thinking, well, you could still have multiple instances of it, and then the port be decided based on, like an environment variable or a configuration or something like that, right? So
Right.
you could still, have multiple versions of it running side by side, right?
Right. Yeah, it's definitely possible. Something like Apache. Just kind of interesting to me that they're kind of pushing these smaller libraries. I forget the Ruby ones, but like I remember when I first started like looking at Ruby on Rails, they were using like Mongrel and fast HTTP at the time, and I was blown away. It's like, why wouldn't you just use Apache? But it just things are changing. And that was like 10 years ago now, but still feels new to me.
It definitely feels like it plays along with the idea of the microservice too.
Yep.
Yeah, there's no question that's part of it.
But this is where too, like, maybe I'm trying to remember back to the first 6. I think this is where like the 12-factor app starts to specifically deviate away, where like some of these chapters are very specific to web deployment, or web applications. Because we talked about in the previous chapters that that they weren't really specific to web app. Like one of them was configuration based that we talked about, right? Like or dependency. I mean, there were just good things in there that really applied to any kind of development that you were doing, whether it be like, an iOS app or an Android app, or, even a simple Hello World app. There were code based things that we discussed about that had nothing to do necessarily with a web based app. But now we're starting to get into the chapters where it's getting really specific to networked applications.
Network, but not necessarily web, because you could create like some sort of app that you listen on a port, and maybe it's taking in EDI information or something like that, right?
Well, they specifically in this chapter, in this section here, they specifically call out HTTP is not the only service that can be exported by port binding.
Yeah, so I mean, basically anything that you're doing, even if you wrote a database engine, right? That's going to listen on a port if you have something. I mean, there's tons of things. So
the important thing here, though, is that like the main takeaway that I got from this chapter was that what they're striving for is that your application should just be listening in on some port that could be configured. You don't care what the actual port number is.
Right.
It may be configured on the client side, or client being like whoever does the installation. But you're going to listen in on some port and you're going to respond on some port. And so that's the service that your application is going to provide.
And you bundled it.
And your things are bundled together to make that happen. And you're not, expecting that your code is going to be statically, use static binding, for example, to be included into another project, right? Or I guess even dynamic binding. Instead, you're providing a service, which is consistent with the previous chapters that we've talked about so far.
Yep. And then one of the other cool things that they talk about here is the fact that when you follow this particular approach here, that means your app can also become a backing service for another app, because your app could basically then be something that can be bound to a port that the other thing is talking to. So this is kind of a way to be able to chain additional things together.
Yep. And, actually one thing I used to shell out for all the time was ImageMagick. So it was basically like a little, Linux utility for resizing images. That was something I used to always have to shell out on. And now, reading this, like it makes sense that I would write some sort of wrapper that would run, basically a service under a port that would handle that. And then, I could end up breaking that off into a separate box or something. And it doesn't make sense that my web application would be running this, potentially CPU intensive operation. It should be able to break that off to another server if I need to.
So let's, we've mentioned the Clearly Tech article many times here. I'd play a game with you guys, but you've probably already read ahead to figure out like which one it's going to be.
It's all right.
Probably.
Well, I guess we can still answer what we think it should be.
Yeah, I'm not hurt a little bit by that last one when I wanted to play with the Stack Overflow report.
It did take me a while to find it on the page, though, if it's any consolation.
It's not.
Yeah.
Surely not.
I would rate this one as being kind of low on importance.
I would go more medium, only from the scalability factor.
Yeah, reading specifically from that Clearly Tech article, they have it rated as a medium, and they say that most runtime frameworks are going to give this to you for free. So again, if we were to take this out of the Heroku environment and put it into like something else, right? Like a IIS app, as an example, you're going to set up the port that your app's going to listen to, when you configure your IIS application, right? But the one thing that you're not doing in that example is bundling IIS. And this is where like some of these, like starting with this chapter 2, it's also going to get kind of specific to certain types of developed applications, right? Like because you don't bundle IIS in with your .NET application or web application, then it kind of breaks this port binding chapter because you're not including it.
Although with the later versions of .NET, you might be doing this pretty soon, right?
Yep.
You're not going to be including IIS though.
No, not IIS, but the actual core runtime that you could put.
But what I'm
out.
saying though is that like they specifically talk about bundling in your Apache HTTPD.
Right.
Right. And that's what I'm saying. Like it starts to get kind of this
very
this chapter
specific.
and the next two start to get specific. Like you can kind of see where their mindset was, but taking abstracting some of that away, there's still good fundamentals here, even though it might not be applicable to everything. And that's the
Right.
point I'm trying to make with the IIS example.
Right. So the next one up is wait. What did they say the medium rating was for? Like what reason they give behind it?
Oh, I said that because most runtime frameworks will give this to you for free.
Oh, okay, got it.
Yeah. And that's where I brought up the IIS example, right? Like you're going to do that configuration there,
Yep.
right?
Okay. So stepping into the next one, chapter, what is this, 8? Yeah. Or part 8 is concurrency. And I actually like this one. We'll get into it here in a second, but this one kind of makes sense. So the whole point is to be able to scale out via a process model. And
Right. Horizontally.
yeah, and it's kind of interesting. So, I mean, we've all got some thoughts on this because this is where it all started to feel very Linuxy to me. But, we'll talk about it here in a minute. So what they say is processes are first-class citizens in the 12-factor app. And by that, what they mean is the app has control over the various process types that exist and then assigning work to those process types. And some of the examples they gave is you might have a web process that you would, handle any kind of HTTP traffic or anything with. And then you might have a worker process that would handle any kind of long-running task. Like Joe brought up like an image processing thing before. Like, so you would assign these tasks out to these different process types.
Yep.
Go ahead, Joe.
Oh, sorry. I was just gonna say, starting to read on this, you're gonna see a lot of stuff about like PID files and stuff like that. And I've been working in Windows environments for a while, so it was kind of a trip down memory lane. But yeah, I definitely think scaling horizontally is definitely a kind of a web notion or a cloud notion, but it's just good practice. And I think like it's kind of rare to work on apps now that don't have some sort of web component to them.
But was it just me though? I don't know when you guys read this what your interpretation was on it, but it almost felt like, well, now so much of this is talking about, you can see this direction that they're going. And I just mentioned about the microservices, right? And there's so many of these chapters that are kind of going towards that route. And that's the way this concurrency part feels. But yet at the same time, this one almost sounds like they're talking about like all of these individual processes are all bundled in as one thing. And then it's like, well, then you just broke that microservice architecture, right?
Well, kind of, except for, so some of the key points that they made on it was not only do you need to be able to task out your processes to different, or task out your work to different process types, but you need to be able to not just do it on the same machine. You need to be able to do it across multiple machines. So that goes back with the microservices thing you're talking about. But what is interesting here is, unlike in a lot of places in the 12-factor thing, is they say that you need to leverage the OS's ability to do the processes or some sort of package that's already on the OS. And I think they called out Foreman was one, and what was the
Upstart?
Upstart was the other. So they say leverage those. Don't try and handle the processes yourself.
And the Foreman was also a great example too, because like I was reading up on some of that documentation too, and that's where it made me. It even brought this thought that, okay, well, you're describing a monolithic application at this point. It feels like,
Right.
Even reading the Foreman stuff, because they were talking about like, well, I'll have a worker process to do this, that they'll handle processes off of this queue. My web process will handle this stuff, and it's like, as I was reading, I'm like, well, why shouldn't those each be independent pieces that
Right.
are one's a backing service to the other, right? Like, shouldn't
Yeah.
the worker process be backing service to the web process, and the web process doesn't care. Like, as a developer, why should I have to care how many of these things I'm going to spin up, right? Like, I don't. I just trust that they're there, and then the actual spinning up of that should be
handled by the server or whatever.
Yeah, like a runtime decision.
Yeah, and the examples that they gave with Foreman, it definitely spins up, processes per application instance. So if you had, 10 applications running on the server, then you're going to have, 10 of these other processes that are associated with it, which is totally the opposite of scalability. You should be able to scale those independently. So I totally get where you're going, Outlaw, and I agree. And yeah, it's kind of strange, but I don't think there's so much hammering on Foreman. I think that was just kind of an example of a tool.
Oh, I don't mean to hammer on it by any means.
Oh, no, I didn't mean you. I just meant like they weren't like laser focusing in on Foreman specifically. It's just kind of a strange tangent and doesn't really line up with the rest of their kind of methodology, I think.
Yeah, well, there's a diagram there where they talk about the scale going up and the workload diversity going across, right? And so on your, I always get the X and Y. X is going to the right.
Yes.
So, okay, sorry. So in your X is your workload diversity, right? And so in that frame, you have web, worker, and clock in their diagram. And then on your Y axis, you have scaling. So for each web, you might have, maybe you have 2 web processes running and you have 4 worker processes running. So you're scaling up like that, right? And they're talking about doing this on the same box. But again, that's where it was like, well, why do I care? Why do I have to manage that? Like, it feels like if I have to have one application that is configuring how many of each one of these things, then I think I've done something wrong if they're that tightly coupled that I got to do that in a configuration.
Yeah, it's weird if you think about it almost from a web architecture standpoint. Like if you talked about like Elastic Beanstalk or something in AWS, you typically set up things to say, okay, I need to scale at this point, like when CPU utilization hits this or so. And so it seems like there should be something else sitting there other than you writing code to say push these.
Well, that's why this one confused me so much.
Yeah.
And I'm not to harp on this one, but this one really was kind of confusing to me in reading it because it really did seem like it contradicted itself and other chapters because they talk about like, okay, so they give this example of the worker process, but it's supposed to be working off of a queue. And they specifically mention that, if it's, any items that it can't work on at the time, then it'll put the items back to the queue. Like, and when I think of queuing, I definitely think of, horizontally distributed, or scaled applications, right?
Right.
I'm not thinking about like I have multiples of these workers processing on the queue that I've manually configured how many of them, and they're all in the same box. But then at the same time, one of the examples they mentioned was a clock process, much like a cron scheduler, where that process's job is to schedule tasks to run on a certain schedule. And I'm like, why would I do that?
Right. Why wouldn't you let the server or whatever handle that instead of you be trying to coordinate all that, right?
Yeah. So I say that because if anyone's listening and they're more familiar with this 12-factor app, and this chapter really made sense to them, I would love to get some feedback on and maybe better understand what they're getting at here, because it really seemed, even reading like some of the deeper links that they had in there, it seemed like it contradicted itself and the other chapters.
Yeah, it was a little bizarre. There's no doubt. And like I said, even if you take, let's get out of the Heroku context here. Like this feels very Linuxy to me because you don't really talk about creating processes in Windows, right? Like a lot of that stuff is managed for you to a certain degree. I guess if you were talking about a schedule or something, you'd set it up in the Windows scheduler, but that kind of goes back to what you were talking about before. Like you just let the pieces kind of handle what they're supposed to. This feels more like, okay, well, I need to tell Foreman to create this process type, and then I'm going to start assigning some work to it, which is not really something that you do in a lot of Windows type programming. At least not in stuff I've done anyways.
One good point I thought they did make was that you should try to avoid your process spinning up and managing threads. And that's because it's kind of an example of vertically scaling, an example of the ImageMagick resizing. If I opened up a thread to do the resizing every time I got a resize request, then I'm going to be maxing out that box when I should be, looking at trying to do that either on a service on that box, to start, and then maybe moving that off to a, dedicated box just for doing that. And so by kind of spinning off these own threads, I'm creating headaches for myself and kind of scaling in the wrong direction.
But then again, they also specifically say this does not exclude individual processes from handling their own internal multiplexing.
Right,
So,
but it's discouraged, I think. I don't know if they said that or if I read that.
Yeah, so...
Yeah, they did say it was discouraged.
Yeah. I wish this one was more clear, because I've loved every other part of it so far until I got to this one, and I was like, well... Because I really like the whole idea of the microarchitecture, like, just building small little pieces of the puzzle and then getting them to all work together. But this one felt like it didn't exactly mesh with that. And maybe it was my interpretation, or maybe it's their wording, or maybe it's both.
And what's kind of funny too is the name. Just like what we've talked about, what we've described in the graph that we've looked at and the reading that we've done, I wouldn't really classify that as being related to concurrency. Mm-mm. To me, concurrency is kind of running things, like independently of each other, not quite at the same time, like parallel, but,
Well, the only part that is where they talk about scaling out to other machines on processes on those, right? But, yeah, I'm with you.
So, in terms of importance, you've already cheated. Why do I even ask?
It's already there.
Yeah, all right,
It
fine.
showed us. What am I supposed to do? I can't close my eyes.
You were supposed to close your eyes. All right, so this one was rated low, and I totally agreed with their reasoning on it.
Same.
And according to Clearly Tech, their reasoning for giving it a low rating was they said, don't worry about this factor until you get pretty deep into scaling considerations. Trust your chief architect or CTO to raise the red flag if this is going to become an issue for you. And I totally agree with what you're saying. Like,
that's good advice.
Because, going back to, we've mentioned the MVP as well, right? In the past, in past episodes, and just get the product out there.
Yep.
Right. Like that should be your primary concern. Get it out there. So.
Yeah. Also, before we leave this one, I did want to mention there were a couple of programs that we had mentioned that I wasn't familiar with before. So I kind of looked them up, and I just wanted to give you guys a kind of 10,000 foot overview of them. One was Upstart, which is it's on Ubuntu, it's on other Linux distributions as well. But if you've ever tried to write a process that would, and I think we've all probably done this at some point in our careers, but you write a process to try and see if another process is running or not. And it either monitors and alerts and lets somebody know either via email or something, or it tries to restart the process. That can get hairy quickly, and you quickly start reinventing the wheel. Well, Upstart is basically a nice, really low-level set of programs for event-based starting, stopping, and monitoring. So it can do really cool stuff like restarting an application as soon as it crashes, because it's based on an event being thrown rather than polling every minute or so often to see if something is still alive. So I thought that was really cool. And the other one we mentioned a few times was Foreman, which is a Ruby gem for basically managing multiple processes. And it's also kind of heavy on the Linux side. And it helps manage either your upstart scripts or your init scripts. So you can do stuff like restart my application, and it will actually restart all the processes that are associated with that in the Foreman file. So it's a nice way of kind of grouping the things that you need for your app, the local things for your app, into these logical units, and it kind of handles the OS side of things for keeping those running and starting, stopping, restarting, and making sure it all is done gracefully. So I thought those were both really cool, and I definitely will be keeping an eye out for those.
Yeah, there was one other thing I wanted to mention too, just going back to that whole thing about the low importance for the concurrency one, and the concept of the MVP and just getting it out there. I was actually coincidentally watching a TED Talk today, and they were talking about like the key factors for startups and why startups have succeeded and why they hadn't, or why some hadn't. And the number one reason, at least according to this analysis, was the timing. Getting it out there. What was the timing right, and getting it out there at the right time. So, when we talk about the MVP, like sometimes it's just more important to get your idea out in the wild. If the timing is right for it, and that means that you're going to have to come back and do refactor and iterate on things later on. So it doesn't have to be perfect the first time.
So, yeah, I definitely like that. And we'll have some resources we like that mention some nice resources for exactly that sort of thing.
Yeah. So with that, it's that time of show again where you hear me beg, as always, and so I'll do it. If you haven't already, we greatly appreciate it if you'd leave us a review. And if you have already, feel free to tell a friend. And we would greatly appreciate that too. Or if you've already left a review on one site and you want to leave another on another app, that's okay too. We don't mind getting multiple reviews from the same people across different sites. So, we would greatly appreciate it. Thank you.
This episode is sponsored by Infragistics. Experts in data visualization, Infragistics developer tools drive custom app development for any data visualization scenario on any platform. And Report Plus is an enterprise-ready, self-service BI dashboard solution that opens up your enterprise big data for end-user consumption. Head over to Infragistics.com and get your free trial today.
All right, so let's get into this last part here.
Let's just dispose of it.
Right? Disposability. That is the last chapter we will be talking about tonight. What would that make it? Chapter 9, I believe.
9.
Yeah. So, disposability. We already threw it away. I already lost my notes on it. Is that too soon?
We should wrap it. Nah. So who wants to kick this one off?
Me, I'm definitely thinking Graceful shutdowns based on the name, but the official sentence is maximize robustness with fast startup and Graceful shutdown. So I definitely I've been in plenty, many thousands of hundreds of millions of situations where people are terrified to either shut down a server or restart a process because they just don't know what the heck is going to happen. And I think this is aimed at that.
We haven't restarted this box since 2003.
Yep. How many times have you been in a company and they're talking about testing their disaster recovery plan, and no one wants to do it because they have zero confidence that they're going to be able to recover with the mail server going down or something.
Yeah, and that's a fair enough fear to have.
Yeah. I mean, when they talk about disposability here, they're talking about like it being disposable, meaning that it could start up or shut down at a moment's notice, so that if you wanted to spin up a brand new instance of your app server, then it shouldn't be a big deal to do so, right? And bringing down another one so that everything rolls to the new one shouldn't be a problem, right? And I feel like we kind of talked about this, or at least we hinted on it a little bit, and I don't remember which chapter that exactly was, but it definitely feels like we kind of hinted about that.
Yeah, and a lot of these are kind of tied together. I'm looking at the list right now. I definitely know they are absolutely positively into the whole, disposability aspect from like, I should be able to shoot boxes in the head. I should be able to deploy things. I should be able to spin up, spin down, no problem. And everything should be stateless too. So everything should just kind of bounce to the next guy, and I should never have any sort of downtime.
Yeah, and one thing we've probably mentioned these terms before. When you hear elastic scaling, all that means is it's able to grow and contract back down, right? Like if you need to scale out to 100 servers from your usual 3, and then that spike is down, then you can go back to your 3 servers or whatever.
I think you forgot a key word there, though. Right? Automatically.
Yeah. You don't want to manually be pushing a button.
Yeah. So it automatically expands or contracts as needed.
Yeah.
And this portion, this chapter doesn't really call that out. Well, they kind of do when they talk about Beanstalk, but it's really, but that's kind of where it's going though, right? Like,
right.
You can see there's this path that these chapters have been going so far, right? And each one has been kind of building on this central theme and leading to the next one, right? And so this idea of being able to spin a process up or down quick in order to bring more of them up or to take some of them down, right? Going back to your elasticity, you can see that's where they're talking about, right?
And you know who does this well? I mean, this is a side note, Netflix.
Oh,
If
yeah.
you think,
Oh, yeah.
if you really want to think about a company that has to scale, they have their primetime viewing, and
Yeah, they're only like 40% of primetime internet traffic.
right. So when you think about it, if you were to consider your application, it got as popular as say like a Netflix or something. It's not like you can have somebody sitting in the room saying, "Oh no, our 10 servers are at 90%. We need to scale up 5 more." You can't do that. This has to be something that can grow organically and come back down to size. So that's what this is about. And they did have some really cool tips in here. Like one of the ones was strive to minimize the startup time, which is not something that a lot of people really think about, right? It almost goes back to being funny about what Joe said. Like, oh man, I don't really want to hit this restart button because it's going to spin and spin and spin.
Yep.
Yeah, I mean, they actually go a little bit step further with the crash only design.
Yeah, that
being
was
like
cool.
the final logical conclusion of where this should go, right? And in that they link to a report that seemed a little bit dated based off of some of the versions that they were talking about, but in that report it was specifically calling out versions of software that their startup time on a clean boot, and here was the average reported startup time versus the startup time on a crash reboot, and yet it was the faster time was on the crash reboot than on the clean reboot.
Wow.
Which was
That's crazy.
unexpected.
Yeah,
Right.
I do that on SQL Server and see which one goes faster.
Yeah.
Yeah, and so in here they reference again, these are all dated, but Windows XP, Red Hat 8, and JBoss 3. So different types of software across the spectrum, right? App servers and OSs, and then, but yet the startup times. So like XP on a clean reboot, according to these results, was 61 seconds, right? And on a crash reboot was 48 seconds, right? Now, you hear me say that and instantly like, oh my God, that's dated. Because
Right. Yeah,
in this
now
world
it's
of SSDs, like we were
Yeah.
talking about in the last
8
episode,
seconds.
60 seconds, I want to kill myself if it takes that long.
Yep.
But
And just the fact that they're talking about XP tells you a lot.
right. But it was still some good information in it, though, about the crash-only approach.
Yeah, they also talked about their shutting down should be graceful. And by graceful, and we've all kind of worked with situations like this before, if you shut down something, you can't just kill somebody in the middle of a process, right? The processes that are running need to finish, and then you close out the connections and you exit. And that's how you want it to happen, and that's how it should happen. And you should do whatever is in your power to make that happen. But that means that you have to enforce some things, like your requests can't be these super long running requests, right? They need to be fairly short lived requests, a couple seconds long, something like that.
So no more kill signal 9. I think that's the one that just like absolutely shuts it down right now.
Well, if you do that, you should be able to handle that too, right?
Well, and that's kind of like, I kind of teased it when I said there was like some good things in this crash-only software design, because that's kind of where that was going, was that, if you look at these systems that, why are they slower on a clean start versus a reboot? And the idea was like, well, then why not just write your app to always be able to
Crash start.
to only do a crash start or a crash shutdown, right? Because if you're able to handle that and that's faster, then why have the other code and then have to maintain that code if it's just slower anyways, right? So just write your application to where it always handles that scenario, and then you get the benefit of it, right?
It was interesting too how they handled that in some cases. So one was setting up queues, right? Because the way like I've done some reading on RabbitMQ and done some listening. But you can set these things up to where if it can't talk to one of the boxes or one of the processes that's supposed to be doing something in the queue, it'll just pop it back to the queue. And then that way something else can pick it up. And that's one of the ways that they talk about handling those kind of situations. Now, that also means, though, that you're going to have some sort of way of clean rolling back whatever was happening, right? If something was in the middle of a process and then it died, if it was database transactions, you need to be able to roll that back. So these are all things that you kind of have to build in. And
I think they even mentioned a few queuing systems where they were talking about, the queue should be able to. There's some process that should be able to handle, like if the worker process hasn't replied back in a certain amount of time or it timed out, that the job just goes back to the queue for the next worker to get it.
The nice thing is, too, now, I do want to say, like, a lot of this stuff that we're talking about right here is not necessarily easy code to write because you have to handle a lot of different situations, right? But if you do implement something like a queue, because a lot of queues do have that stuff built in, you can almost offset some of your own programming into functionality that's already built in other stacks. So it's something to consider. I mean, a lot of people don't use queues, but there's some benefits to be had by leveraging that kind of functionality.
Yeah, one example I think of here is I've done this a million times incorrectly, is if I have some sort of process that needs to do a bunch of work, I will query all the things that need to happen in one query, and then I'll loop over and do each one. And the problem is if that's, quits in the middle or something, or if that process gets run, say, twice, then you potentially start doing some of these things twice. And a better approach is to basically, back to the DB example, is you basically, query for one row, do that work for one row, then query another one. Now I can spin two processes off at the same time, and it's not a problem. And if it, gets killed in the middle, I can start back up without worrying about what's going to happen. And basically what I've done there is just reinvented a queue in, a database.
Right. I mean, not to harp on the crash-only design, because I don't want people to think that they should just go and, hit the power button on their computer to shut it off instead of doing a graceful shutdown. But in this chapter, though, they do say that the 12-factor app is architected to handle unexpected non-graceful terminations. So basically what they're trying to get at is that your application should be robust enough that if I just come and yank the power cord out of the machine, it's not going to destroy anything, right? Like, things will be able to continue on, right? Some other process will be able to pick up where that machine left off, and that machine, when it comes back up, or that process, when it comes back up, isn't going to be in a corrupt state. Like, that's ultimately where we're going at with this.
Yep. And like I said, that's not exactly easy to do depending on what kind of technologies you leverage. If you are leveraging queues, that can greatly simplify what you've got to do. But if you've got some sort of process flow and it all has to happen, A, B, C, D, E, F, G, and let's say that you got 30 steps in that and something dies on step 26, you have to have built something that knows how to, fix kind of where you were in that process.
But if each one of those steps was another job that was added to the queue, then that solves your problem. So that's where the architecture comes back in, right?
Yep.
So and it doesn't necessarily have to be the queuing like Joe mentioned, right? Like, so using the database could be how you
it's a way to do it,
queuing mechanism,
and it's a way a lot of people do it, right? I mean,
well, I don't know if I'd say a lot. And if we're thinking about like in the cloud environment that we live in today, right?
Yeah.
There's definitely a lot of cloud queuing options out there.
Yep.
Right.
Yeah. Also, wanted to mention, SQL data, like, transactions are easy to do in most ACID compliant databases. But when you start talking about external services, where writing to this service, writing to that service, and something gets killed along the way, that's really tough. And like you mentioned, the queue is a great way of solving that.
Yep. I mean, that's pretty much it for disposability.
So I can't ask my question because Alan's already cheated. And
I haven't read the reason.
Ah, fine.
I can only see the rating.
Okay. So this one was rated as a medium, right? You agree or disagree?
Is there something between medium and high? It's no, because I've cheated and looked at all of them.
Oh,
But I wish that there were for this because it's really hard to get it perfect, but that doesn't mean that you shouldn't pay any attention to it. So yeah, I'm gonna go with medium.
I agree. This one's medium for me, not because of how important I think it actually is. Like I put this up there closer to high, depending on what the system's doing. But the reason why I put it at medium is going back to the MVP thing, because I'm very much into get something that works out there, right? Like get your product out there. And the problem is you can spend a whole lot of time on this and never even come close to perfecting it. So
if you're talking about like trying to break things off into queuable work items,
bite-sized chunks,
that and then spinning off a bunch of different worker processes, and that's all. Those worker processes are all code that you got to write. Like, I can totally understand where you're coming from with that.
I like this one a lot. Like if you had unlimited resources, unlimited amount of time, this one would be high for me. But because of the kind of resources and time you would have to put into this to make it perfect, that it's definitely closer to medium.
I feel like this is an iterate until you get there,
Absolutely.
right? But
And the important parts too, right? Like the mission critical parts, you should do this on. Like if your business is
maybe start out with some of the not so mission critical ones just to get your
Get your
pattern
feet wet.
down, right? Work out some of the kinks in your queuing and worker process system there, right? Whatever platform that is that you're using.
But so I guess the reason I say this is, let's say that your application is a bank wire transfer, right? And it's got to do several steps to get your money out of one account into another account. That thing should be perfect. Like if you have software that does 5,000 other things, but that is one of them, that needs to be perfect.
But that's actually a great example of what we're talking about here, though, right? Because if that job dies in between, in the middle of that, then that job should just go back on the queue.
That's what I'm saying. That's where I'm saying this needs to be implemented perfectly.
Oh, okay.
Yeah.
Sorry.
So the rest of your app, whatever, right? Like, don't even focus on that. But this part is mission critical because you can't take money out of my account and have it sitting in limbo somewhere just because your server crashed.
So I wasn't too crazy about their reasoning, though, here. And, I mean, I kind of get it. But, again, clearly text description for why they said a medium is they say depending on how often you are releasing new code and how much you have to scale your app traffic up and down on demand, you probably won't have to worry about the startup and shutdown speed, but be sure to understand the implications for your app.
So they only care about the scale problem as opposed to what the other implications would be.
Yeah, so definitely like in your banking transaction example, like they're not addressing the criticality of that unit of work.
Right.
Right. That it's either seen to completion or it's not. Right. Almost like a database transaction, commit, on a database transaction. Right. Yeah, they're definitely more concerned about, the scalability of your application. And again, if we're thinking cloud, right, that kind of makes sense.
Yeah.
I think we disposed of that one.
We did.
Cha.
It is gone.
Yep. So on to resources we like. We talked about a few things in this episode that remind me of some books that I like, and I just found out that one of them, in the Phoenix Project, which is I don't think I mentioned on this show before, but I'm a big fan of this book, so I wouldn't be that surprised. But it's basically it's fiction, but it's kind of like a DevOpsy kind of romp through like a IT company. And it's a really light read, and it's really fun. And it's you're going to hear stuff that you hear in the workplace, like things like Kanban boards and change management and stuff. But it's actually an entertaining read, and it's easy to root for the main character. And I just found out that it's on Audible, so that's huge because I hate reading. Also, another book which is on Audible, also fantastic, is The Lean Startup. And that's actually a book that I think defined a lot of terms like MVP and a lot of stuff, and that's where it comes from. It's got a lot of case studies. It's also a surprisingly light read for such a good book. So I would definitely check those out, and we'll have links to those in the show notes.
Yeah, I mean, if you buy both of them, you're at under $20 if you do it on Kindle. So
Yep.
Yeah, very nice.
Yeah, and we'll have links to, obviously we'll have links in there for the 12-factor, 12factor.net and Clearly Tech. And I've said this before, but just in case, if this is the first of the 12-factor episodes that you're listening to, the website for that is 12factor.net. But everywhere else, 12 is spelled out. So just be aware of that. And the previous episodes for the 12-factor app that we've discussed are episodes 32 and 33.
And we're almost done. So we'll probably have one more episode, right? And we'll go over those last 3, and then we'll be experts in DevOps.
Yeah. It's going to be awesome. Looking forward to it.
Yep.
All right, so let's get into Alan's most favorite part of the show. The tip of the week.
Of the year.
Of the week.
All right. And this time it actually is a week. How about that?
Is it?
So
Is
it? So my tip actually came from something stupid that I did recently. That you're coding, you're in a groove, and you do something, and you get an error, and you're like, what? Come on. And then you realize that you did something stupid, and then you have to figure out a way around it. So essentially what I was doing is I needed to go through and I needed to replace some things in a list, like maybe some properties or some values. And if you've ever done a loop over any kind of list and you try to change something in it, typically you're going to get barked at because it's going to be like, yo, you changed the list. We can't keep enumerating this list, right? And so one of the ways that you can handle that is, and this goes back to episode 2, by the way, where we talk about boxing and unboxing and .NET. We talk about the stack, the heap, and pointers and all kinds of stuff. There's a lot of people that probably skip that because it says in .NET. This works the same in Java as well. And anything that's running a virtual machine pretty much that manages a heap and all that. But essentially what you can do is if you're looping over that thing, let's say that you want to replace something in that list, you can't change anything on the fly because then it's going to say it changed and it doesn't know how to enumerate it anymore. So you can keep track of the changes you want by having like an external list. And then the way that I do it, or did in this case, is I kept a dictionary of the previous object and then the new object that's going to replace it. So I loop over the list, I find out what changes need to happen, I create a new object that basically is a copy of that other object and just change the property I need in it. And then when it's all done, I can just swap out those items because everything that was in that previous list is pointing to some space in the heap. And so all you're doing is telling it, okay, point to this new spot that I've got. So you can basically swap out that object.
Yep. I totally did this today, by the way. I was
You too?
looping through a list, and I was removing items from the list as I was looping through, and then I ended up getting an error because my link didn't line up. And so I ended up creating a list of items to remove, and after I ended up looping, then I went back and removed them.
Yeah, it's really a nice little pattern, and it doesn't take up that much. I mean, now granted, depending on how many objects you're trying to throw in here, it could be a problem. But yeah, man, it's a nice little pattern, and it'll keep you from doing anything that'll just crash you. And it's a bit of a minor annoyance, but it happens, right? Like you're just thinking, you're like, okay, I need to do this, and then oh yeah, that's right, you can't do that. So
there ought to be a design pattern for this.
So make a list of only the things you want to remove or
so
modify.
Mine was modify. So basically what I did is I took the item that I needed to change, I put it in a dictionary as whatever that type was, right? And then I said, okay, we'll make a copy of that thing, but now change something and make that the value in this dictionary. And then that way, all I had to do at the very end was say, okay, replace this one with this one, done. And it automatically just changes the pointers out behind the scenes and it'll get garbage collected. So it was beautiful. And I happened to be working with J objects because it was all dynamic objects that were created from JSON and all that and C#. So it was pretty interesting. It was fun. Maybe I'll try and get some sample code together. Who knows?
Yeah, I'm very familiar with that kind of pattern of doing things, and it's not natural to me, but it's something I keep trying to do where basically I try not to modify any of my, kind of inputs. So like I'm always trying to basically do what you're talking about where I, have a new copy, I do my work there, and then I swap them at the last second.
That's it. Yeah. And
it's
it
like
works because
faux functional.
it is kind of, yeah, because it's all
not
immutable.
functional.
Right.
but yet you want it to be like functional programming by not changing the original source.
I mean, the beauty is if you
I'm going to create a whole new programming paradigm called faux functional.
I mean, the beauty is if you actually understand how the heap works and all that, and they're all pointers, it makes perfect sense, right? Because now it's just pointing to that new object instead of the other one.
I'm going to register FO functional.
There you go.
Dot.
Wait, wouldn't it be FEAUX?
No, that'd be. I was trying to make a
Or
joke.
FAUX.
Yeah, I was trying to make a joke, but your bad spelling ruined it.
Yes, it was all. It might have enhanced it.
Yep.
So that's
Well, because I was going to leave it up to interpretation what the FO was.
And I also think it makes things more refactorable because you can kind of copy and paste lines around a bit more without worrying about the state of individual variables.
That's cool, man. I'm actually glad somebody else had this problem where they were coding and they're like, "Oh, yeah, that's right. I can't do that."
Yeah, literally today, and it never comes up, but it did today.
Awesome.
Speaking of things that never comes up, I guess we're up to my tip. And I feel like there should be a name for this too. And this is the kind of thing that nobody really does anymore because like every language has nice ways of iterating through collections now. But if you're messing around with any sort of like game programming or just multi-dimensional arrays for some reason, one kind of trick that is kind of neat that if you're, let's say we're iterating through a two-dimensional array for a maze, like a Pac-Man maze or something, and your first inclination is usually to go X then Y, probably a byproduct of using English and Cartesian coordinates. We always say X and Y. We list the X first and then the Y, but it's actually more efficient to loop based on the Y's first. And so what I'm talking about is we're doing 2 for loops for X equals 0, X less than length, X plus plus, and then inside that you would do a for X equals or Y equals 0, Y less than length, Y plus plus. That's kind of the natural way to do it, but if you actually swap those, then it's much faster on the computational level, and that's because at that point you're actually iterating through the inner array first. And so rather than your pointer slopping back and forth between these two arrays to get the next value, it stays in the same array and it just increments the actual index by 1 until it gets to the end. So it looks a little funky, but it's and it's definitely a micro optimization, but you'll look like it, you know what you're doing in an interview, maybe.
Interesting. I need to see a code sample.
Well, there's one right there in the show notes.
And we'll have it on the website.
It's not doing it for me.
Yeah, if you're looping through,
it's basically
4X,
it's basically like this. It's backwards.
first.
So
I know it's
hipster
backwards.
programmers do it backwards.
I know it's backwards, but how are you referencing that inner item first?
Because you're going through the Y loop, and then inside of that, you're going through the X loop.
How's that different than reversing Y and X as variables? I guess that's what I'm missing.
Because we're talking about multi-dimensional arrays or arrays of arrays.
Right.
So if you did the X first, you're saying go to array number 0, then go index number 1.
Okay, so you're going through the last segment of that multi-dimensional array, going through all pieces of it before you go to the next item at the top level array.
Right. Otherwise, you're swapping an array each time. So it's just kind of a bigger hop.
Okay, I got you. No, that makes perfect sense.
Definitely micro, but it's kind of cool.
Cool.
Yeah, I'd really be curious based on like current memory speeds, how much of a problem
matters.
that is.
I feel a JS perf coming on.
Yeah.
Oh,
You
okay.
can do it. Well,
Okay.
I'm not doing it. You can do it.
Oh,
I just say
I
I'm
feel
gonna
like this
do
is
things.
Joe's tip. Like, why am I getting the work here?
Well, I always say I'm going to do things and
Oh.
then forget about them conveniently. So
All right. Well, then this next tip is for you, then, Alan. This is your tip right here. You want to pay attention to this one. So actually, it was Alan that brought this up,
Yep.
or that I mentioned it
Triggered
to
this.
Alan, and Alan said, "Oh, that's a good tip," and I was like, "Oh yeah, I'll use that for the show." So this was my pro tip to Alan, was to set a calendar task to remind yourself to change your password. So if you are in a corporate environment where there's a password policy in place where you have to change your password every so often, and specifically, this is more specific to the actual commands are going to be specific to a Windows, domain controller environment. Then you can open up your choice of PowerShell or command prompt. We won't talk about it. And issue the command net space user and then your username, your domain username, space / domain. And that will generate a report that'll show you about your user ID, and included in that output will be a little line that says password expires, and it'll have the exact date and timestamp of when your password expires. Now you take that little gem right there and you go over to whatever your calendaring application of choice is and create yourself a task or reminder for that date and time to change your password, and add an alert to that or a reminder to that task to for a day or however your choice, however many hours or days ahead of that time that your password is going to expire. That way you have like a little countdown of, like, if you're in Outlook, for example, and you create a task with a reminder alert, a week ahead of time, for example, then you have an exact to the minute 7-day advance notice. Hey, your password's going to expire. Yeah. And then you can just choose to keep hitting the snooze button until the last minute, or choose to do it right then or there. Whatever your choice is, you keep getting that reminder until you do it.
Yeah, it actually is pretty cool. I mean, like you said, you just type in that command and it gives you the second that your password will expire.
Yeah, and that's your when I say your username, I'm just talking about the short portion of your username. So you don't have to include the @ in your company name or whatever. So just whatever your short username is. So like if your username that you usually log in with might be John space Doe, right, at examplecompany.com. Instead, we're talking about just, if the short name for that was just JDoe, then it would be net space user space JDoe space / domain.
Yep, and not the domain you're on, the actual word / domain.
Right, yes, sorry.
Yeah.
Yes, the actual word domain.
Yep, works perfect.
Yep, and you'll learn all kinds of little interesting things about your credentials. Nothing crazy.
No, it's not that juicy. All right.
You guys don't change your password every day?
Right.
Good to
That would
know.
definitely be a serious password policy right there. There's actually some philosophies out there that having policies that enforce their employees to change their passwords often isn't necessarily the best way to go.
It's not necessarily the best. It's usually the worst, because then it ends
up
one. Being, my name 2015, my name 010203.
Some of the reports out there were suggesting that, or some of that philosophy was based off of reports that suggested that it encourages people to write down their password, or save their password underneath their keyboard, like really bad habits like that, and that instead it would be a far better environment if you just encouraged high entropy passwords.
Yep.
Super long passwords or passphrases, really, and maybe be more event driven with your policy rather than forcing people to remember something new every 90 days, because then that's where your username 123 comes in.
Yep.
Or whatever you said. I don't remember.
It's all based off numbering. So,
but yeah, so that's episode 35. I hope you've enjoyed listening to chapters 7, 8, and 9 of the 12-factor app, port binding, concurrency, and disposability. And as I mentioned before, be sure to check out episodes 32 and 33 if you haven't already listened to our takes on the first half of the 12-factor app. And as always, be sure to subscribe to us on iTunes, Stitcher, and more using your favorite podcast app. We really do appreciate those reviews. So you can go to www.codingblocks.net/review and find links to quickly get you over to iTunes or Stitcher to leave a review there.
Yep. Contact us with any questions or topics. We seriously love getting those. We love answering them, and hopefully it helps you and anybody else out who's listening. And visit us at codingblocks.net You can find all our show notes, our examples, discussions, and more. This particular episode will be www.codingblocks/episode 35.
That's right. And send your feedback, questions, and rants to comments@codingblocks.net. And make sure to follow us on Twitter @codingblocks. And we're also on Facebook and Google Plus and Pinterest.
And LinkedIn and
And we will totally endorse you if you friend us on LinkedIn.
Oh my God. You're still doing that?
Here we go again.
Yep.
Joe will endorse you.
It's my little LinkedIn Ponzi scheme.
That's awesome. All right, so we will be back and talk to you soon.